Today we're going to talk about Docker for Java developers. My name is Arun Gupta. I'm a Java champion and I'm a Docker captain. That means both of these communities have recognized me as an individual who know a few things about the technology and how they work with each other. Um, I'm an avid runner. I like to run. I've done several marathons around the world. And something else that I also passionately believe in is educating kids and getting them excited about technology, keeping them engaged in STEM. So as part of that, I run this organization called as DevOps for Kids. And I founded that in the US, basically bringing the effort that was started in Belgium to US. And something else that I'm very proud of is, I wrote a book with my son on Minecraft modding with Forge. So if you are an 8 or a 9-year-old, if you have an 8 or a 9-year-old kid who is addicted to Minecraft, but you would like them to get started with Java programming, this is a perfect segue for you. All right, let's talk about the geeky stuff here now. So what is Docker really? So Docker is an open source project and company. So here, if you go to github.com/docker/docker, you can see, it's extremely popular. The number of stars, number of forks, number of watches, number of commits, number of issues by all standards. If you see, it has been extremely popular. What does it really do? Well, it allows you to create containers for your software applications. We're not going to dig into the details of containers, what containers provide, but essentially it gives you an ability by which you can package your entire application all the way up until operating system and JDK and database and drivers and all the configuration, etc., into one standard Docker image. And then it gives you the ability, what we call as PODA, which is package once, deploy anywhere. Okay, so let's talk about that in a second. Now, we are Java developers. We know exactly what WORA is. That's what JVM or the Java language gave us. Essentially, what we do is we create an archive, which is either a jar or a var or an ER. And once we get that going, that jar, var, ER, that archive could run on a variety of platforms, whether it's Mac or Windows or Ubuntu or CentOS, because you have a JVM ported over there. The JVM understands the bytecode, and so you really truly write your application once, and then it just runs seamlessly, natively on all of those platforms. In that sense, similar sense, what we do is we create a Docker image, and that Docker image, is the ability by which you package your application together, not just WAR, but maybe your application server and the configuration files and the drivers and everything all together as a single image. Now that Docker image could run on a variety of platforms. Whether it's Mac, whether it's Windows, whether it's Ubuntu, whether it's CentOS, they all have native support for Docker. So the cool thing is, they could run over there. Now, PODA is not exactly like WORA, because in WORA, truly no change is required, but PODA it has a dependency on how you build the image. What is the base operating system that you're using to build the image? So if you use one of the Linux flavors to build your image, then it would run on any of the Linux machines. Now with Windows 2016 Server, which is Technology Preview 5 at this point, they are they have support for native Docker as well. So you can actually use Windows as a base operating system over there. So it's not exactly like PODA, but the concept is very similar. So what is Docker mission? At a very high level, the broader Docker mission is to be able to build an image. Once you build that fantastic image, you need to share it with somebody. And so you ship that image, and we'll talk about what do you mean by shipping and how you ship it. And then once you share it with somebody, then somebody else could possibly be able to download that image and run that image. When you build, it's called as an image. When you ship, that is called as a registry. When you run, it is a container. So build, ship, run, image, registry, container. That's how you think about those higher level concepts. Now, what does it give you really? It gives you the ability to build your distributed applications very easily. So whether you want to build a classical Java application, yes, I'm talking about Docker for Java developers, but it is truly language agnostic, platform agnostic in that sense. Whether you want to use Java, Ruby, PHP, whether you want to use relational databases or NoSQL databases, whether you want to use message broker, all of those could be packaged up as a Docker image. Then together they can be shipped and then run as a container. So your application is essentially a bunch of containers running across. Now those containers are typically running on either your local laptop or in the data center or in the cloud. So that's the beauty of it. Typically, one of the most common questions is, how is Docker different from virtual machines? So I will give a huge props to docs.docker.com. That is my most authoritative link if I want to learn anything about Docker. So that's where I find out all the information. So on the left, for example, this image is actually from that itself, from the Docker docs itself. So essentially, if I want to look at on the left side, that's my standard virtual machine operating environment. Now, at the bottom layer, of course, there's the infrastructure. There is a host operating system. So let's say what I'm running right now is a MacBook, and then I have a OS X. On top of that, I could run a hypervisor. It could be a type 2 hypervisor, say, let's say VirtualBox. And then if I want to run an application using Ubuntu on top of Mac, what I would do is I would install Ubuntu operating system, which is about a gigabyte of download, maybe more. And then I will bundle my application in there, and then I'll configure Ubuntu and do all that drill. Now, if I want to run another application with, say, let's say CentOS, then I will install CentOS operating system. It's a full-blown operating system. So essentially, I have a host operating system, and on top of that, I install a guest operating system, and then I bundle my application in there. Now, let's take a look at it on the right side. Same infrastructure is not a host operating system. It's just an operating system, first of all. So I have only Mac OS X here. On top of that, what I install is a Docker engine. Docker engine is, think of it as a tool that provides that virtualization layer. It's a process that gives you the ability to understand what Docker image is going to be. That is, the Docker engine is a process which runs your Docker containers essentially. So what you do is then you bundle up your application. In your application, you have a minimal operating system. So as opposed to 1 gigabyte plus of Ubuntu operating system, you have 180 megabytes of Ubuntu minimal operating system as part of your Docker image, and that's what is running. And so a couple of things that really gives Docker that speed, the agility, the popularity is, first of all, once you build a Docker image, is small, so it gives you high density in that sense. So as opposed to running 3 guest operating system on my MacBook, I could run maybe 50 containers very easily on a MacBook because of the small size and the memory requirements, etc. So that's really cool. The second part of it is, when the Docker image is built, is essentially built as layers. Each layer is read-only, so it's a read-only binary. And because it's a read and is immutable, so that's again what gives it the speed. So you get the agility with Docker, you get the speed with Docker. Let's take a look at a little bit more about the build aspect of it now. So how do you build? Well, you essentially use a text file. The text file is typically called Docker file with capital D, and in the text file you say, this is my canonical Docker file. Here I'm saying from Ubuntu, and there I'm saying, oh, this is my base operating system. And then when you fire up the operating system, then I'm going to say, I want to run a command called as echo hello world. That's all. That's all it takes to build you a hello world Docker image. Okay, let's take it a little bit more fancy. Now, if I need to install a Java application, does that mean I need to say from Ubuntu, install JDK in there and everything else? Not really. Well, that's where the second image, which is shown on the bottom, is very helpful, where it says, oh, I'm going to use Java as my base operating system, so to say, because Java is an image that is somebody else has created. It's, by the way, it's an open JDK based image. And so all you're going to say is from Java. Now, if you essentially in Docker world, it gives you the ability to create hierarchical images. So here what you have is Java. If you look at from Java image, that Java image will have a Docker file, and in that Docker file it have another from, which will probably be Debian, and so on and so forth. So you have multiple images that are that can be repurposed to create other more useful images. So for example, on the top, what I say is from Ubuntu. On the bottom, I say from Java. So that's the image that I'm going to start with. So now, and in that image, it is assumed that OpenJDK is already installed for you. Okay. So now, once I say from Java, then I say copy. I have a jar file that I copy to a particular directory, and then my command changes where I'm saying java-cp, take that jar file and run my app. Very simple. Okay. So the important concept here is to understand is you start with a Docker file, then you don't have to start with the base operating system all the time. You start with images that are more commonly that are created for you, which are actually common purpose images. So from Java, for example, and where you can explore what these images are, go to hub.docker.com, where you can see all sorts of images that are available. What does a typical Docker workflow look like? Well, in terms of a Docker workflow, essentially what you have is a client, which is a binary, where how you interact with the Docker host. So, well, first of all, there are three components: client, Docker host, and registry. So if you look at the right side, registry is where all the Docker images are stored. Anybody and everybody can create an image and push it over there. So in this case, for example, I have a Couchbase image, I have an Nginx image, I have a CentOS image, so on and so forth. Okay. Now, Docker host is where your Docker daemon is running. It's a process which understands the request coming from the client and passing it back to the registry. So Docker host is a machine where your Docker daemon is running. Essentially, that's where your images are downloaded and your containers are run. Now, on the far left, I have a Docker client. So Docker client is mostly a dumb proxy, which basically gives a command to Docker host. A client can be configured to talk to a host or a multiple hosts. We'll talk about that a little bit later. But essentially, the client makes a command. It goes to Docker host. It says, okay, I want to run a particular container. And it says, okay, for the container, I need to download the image. Do I have the image? If I don't have the image, I'm going to go talk to the registry, download that image, and then I'm going to run the container. Nothing happens on the client. The important part is that everything, whether the image is downloaded or the container is run, or is on the host. Okay, and registry again is where all the images will live. So that's sort of the typical workflow. Now, on a given day, you could have a client point to one host, which is running on your local laptop. It could be running on Amazon, or it could be running on any cloud provider. That is perfectly normal. So, but Docker is a native Linux technology. Now, being a native Linux technology, how is it supported on Linux, well, Mac, and Windows? And why is it a native Linux technology? Basically, it uses concepts like C groups and namespaces and things like that to provide you that sandboxing of security, etc., on your Docker container. So, in order to run Docker on a MacBook, for example, or a Windows, you can use something called as a Docker machine. Well, Docker machine gives you the ability to create Docker host on a computer or a cloud provider. Again, it's a CLI. So you say Docker machine create, and you say -- driver VirtualBox. When you create Docker machine, you need to say what driver you're going to use. On my MacBook, typically, if I want to be everything local, then I will give VirtualBox as a driver. But if I want to create a Docker machine on Amazon, then I can actually give that as a driver. So whatever the driver is, it basically creates your Docker machine on that particular on that particular virtualized environment. And of course, the last parameter is the name of the virtual machine. So now, once I create Docker machine, then I can say configure Docker client to talk to a host. Essentially, it's all done using environment variables. Then I can create and pull images, and that's the command issued by the Docker client for the Docker host. I can start, stop, restart containers, and I can upgrade Docker. Now, Docker has a very good release cadence. So they typically announce releases every 4 to 6 months. So what that means is, if you have a Docker machine running, there's a Docker host up there, and it's for a particular version. So like, let's say 1.11 today. Now, in 3 months, let's say if they release 1.12, then you will have to upgrade Docker. So there's a capability in Docker machine by which you can upgrade to the next version of Docker as well. And what you get for that is new features, etc. So something to understand is, there is a machine core, which is the ability to create machine, but then there are a bunch of virtualization providers. So remember, we looked at Docker, VirtualBox as a machine provider, but then there are a bunch of other providers as well. So I can create a Docker machine on DigitalOcean or GCE or EC2. You pick your favorite provider and provision it over there. Now, the cool thing is, these are all APIs well defined. So if you want to create a provider for your own virtualized environment, you can write a provider for that as well. Now, Docker for machine, Docker machine essentially requires you to have VirtualBox. So that's an additional dependency, as a matter of fact. Something else that has been recently introduced is Docker for Mac or Windows. Now that provides, first of all, where do you get it? You get it from beta.docker.com. So if you want to sign up and you want to download Docker for Mac, you can do that here. But essentially what it gives you is native user interface. Docker for Mac, and I've played with that one because I'm a Mac user, but essentially it gives you native Mac application, which is literally in your Finder and Applications folder, and that's where your Docker for Mac is. But it gives you native user interface, seamlessly integrated with Mac, and auto update capability. So instead of saying Docker machine upgrade, which is the previous case, here it'll automatically upgrade it. And I installed Docker for Mac a few days ago, and then I had the ability to automatically upgrade it. Just a command line. Actually, it comes in the dock bar. And how does that work? Well, it's a native user interface. So the biggest difference really is it does not use VirtualBox. So you don't have to have VirtualBox for it. And how does it work? Well, on OS X particularly, it uses Xhive virtual machine, and it uses the hypervisor.framework, which is a new functionality added in Yosemite onwards in OS X. So it builds upon that, and it's an Xhive VM. And that Xhive VM itself is managed by Docker itself. So it's a very native application in that sense. And similarly on Windows, it uses Hyper-V VM, which is again the virtualization framework baked into Windows itself. So in both OS X and Windows, it's providing a native experience in that sense. A lot of other improvements in Docker for Mac. It has better networking, file system modification, integration with iNotify, particularly on Mac. So there's some cool things that you want to take a look at it. Now, of course, Docker for Mac is by invitation, but you can still go to beta.docker.com and sign up for it. Now, let's say you don't get your invitation for Docker for Mac. So what is your easiest way by which you start up with Docker? Well, Docker Toolbox. So that is, just Google for it, or you can go to docker.com/toolbox. But essentially, it gives you a bunch of tools. They're all put together where it gives you a seamless experience to get started with Docker. So it has the Docker client binary. It has the Docker machine, which gives you the ability to create Docker host on your Mac or Windows. On Unix, of course, it's a Linux, it's a native environment, so you can say yum install or Docker or apt-get. Docker Compose, we'll talk about that in a second, is again another command line utility that allows you to run multi-container applications. Kitematic is a graphical user interface. I generally don't use it, but if you are into GUIs, then you're welcome to use it. Boot to Docker is the ISO file, which is actually used to create the virtual machine. So that's one relevant part here. And then VirtualBox, of course. So it's one toolbox that you download, and everything it allows you to get started with it. Now, let's say I want to run a Couchbase server. Okay, I want to run a Couchbase container rather. If I want to run a Couchbase container, I want to access an administration port. I want to access its query port. Well, first of all, what is Couchbase? Well, Couchbase is a NoSQL document database. And I want to run it, so I want to access the administration port, query port, etc. So I will have to run the container, which will automatically download the image, but then I'll have to expose the ports as well. I can do that with using Docker Compose. Docker Compose allows you to specify a service. It says version 2 at the top because there was an older version of the Docker Compose. This is a newer version. Essentially, you're defining services, and I say the service name is DB, and I'm giving the image. I can say, okay, map the volume to my local drive so that I can store all the data over there, and then I'm exposing a bunch of ports. So this is okay. I can do this on a command line as well. There's a corresponding command line to it. But where the fun starts is, hey, I want to run my application that consists of 2 containers. Now I want to run with Wildfly and Couchbase. Those are my 2 applications. And all I want to do is I want to deploy my Java application in Wildfly, which will then talk to Couchbase and then expose REST endpoints over there. So the moment I'm running 2 containers, that's what makes my application, that's what makes my command line tricky. So let's see how I do that. Well, what is Docker Compose? Docker Compose is the ability to define and run multi-container applications in Docker. And how do I do that? I do that using configurations, configuration files, in one or more files. By default, the file name is docker-compose.yaml, and you can of course have a docker-compose.override.yaml, which will override the definitions that are given in docker-compose.yaml. it's an optional one. You don't need to have it, but we'll talk about a use case for this. You can of course have multiple Docker Compose files, and each file could be specified using -f. All paths that are given in the Docker Compose file are relative to the base configuration file, or whatever file you specify using -f as the very first one. Docker Compose really allows you to minimize the impedance mismatch between dev, staging, and CI, and we'll see that in a second. So let's take a look at it. I'm going to fire up two services now. So this is a slight variation of the file that we saw earlier. This is still docker compose.yaml. I have two services here. One is DB, one is web. I'm firing up, DB is my Couchbase. It's my Couchbase database. And then I'm exposing certain ports. And then in the web, I want to fire up jboss/wildfly. That's my favorite application server. So I'm going to fire that up. And then in terms of environment, the fun part here is I'm saying Couchbase URI equals DB. Now, DB is my container name of the DB. Now so all I'm saying is Couchbase URI is DB because essentially when your application is deployed on Wildfly, it needs to talk to the database using a JDBC URL, or it needs to know at least the host where the database is running, and that's how the connection is happening. So literally, that is the only connection that you need in this case. Okay, but think about it. This is one Docker Compose YAML that allows you to fire up two containers very easily. Now, one of the cool functionalities in Docker Compose, which we talked about earlier, was the ability to override the compose file. So let's take a look at it. Here I have my Wildfly as a service name. Image is jboss/wildfly. I'm specifying the ports, and the port syntax is 8080 port in the container is mapped to the 8080 port in the host. First is container, second is host. Now, if I have Docker Compose override.yaml, I can say, oh, by the way, this is the wrong syntax actually. It should be 8080:9080, because essentially what I'm saying is now expose the port on 9080. So essentially, if I have these two files and I say Docker Compose up-d, now my port is going to be exposed on the 9080 as opposed to 8080. Another example. So we talk about minimizing impedance mismatch. So how do I do that? Well, take a look at this. Now I have a file which is dockercompose.yaml. I have a container name as dbdev. I have a web service where I'm saying the image name is arungupta/wildfly. And the important part is when I'm saying environment, there I'm saying dbdev, and I'm pointing to the dbdev over there. Okay. Now I could have another file called as production.yaml, and in that production.yaml, I could say my Couchbase container name is dbprod, and I can configure it the way I want to configure it. And then my Wildfly, I can say the environment is db-prod as opposed to db-dev. Okay. And then I can also change the port numbers. So here I'm saying port 8080 is mapped on the container is mapped to port 80 on the host. So that's kind of cool. Now I can start changing those mappings essentially. So if I say Docker Compose up-d on the first case, it's just going to fire up my development environment. If I say Docker Compose up-f, these two file names, it's going to start up my production environment. So you can try to minimize, following the dry principle, try to put all of your common concepts up in dev file and the ones that you care about in the prod file, and then start up the application accordingly. All right, so far we have talked about a single host, how we can run Docker on a single host. Well, what is Docker Swarm? Docker Swarm gives you the ability on how you can easily run multi-host Docker containers. So this is native clustering for Docker essentially. It provides a unified interface to a pool of Docker hosts. Essentially, you have multiple Docker hosts, maybe create a Docker machine or native Linux machines, but you can provide a unified interface to them as a single entry point. It's fully integrated with machine and compose, and what that means is if I have a Docker compose file, depending upon what environment variables are set, my Docker compose file would be directed to that Docker Swarm cluster. Or when I'm creating a machine, I can say, oh, are you a standalone machine or are you part of a Swarm cluster? So that's kind of cool. It serves the standard Docker API. What that means is, if I have configured my Docker CLI to be talking to a Docker Swarm cluster, the behavior stays exactly the same. What that means is The Docker CLI can talk to a Docker host using a REST API, and that's the mode of communication anyway. But then when it talks to a Docker Swarm API, it's exactly the same REST API that is being served. So what that means is your existing tools, whether it's CLI, whether it's Jenkins, whether your custom tools, if they are honoring the standard remote API offered by Docker host, they don't break, but they allow you to scale. Docker Swarm is now 1.2. It's ready for production, essentially. And it says one of the cool features that was added in 1.2 is how you can reschedule containers when a node fails, actually. So if a node fails, the container will be rescheduled on a different node. And if a container fails, then you can always set the policy as a restart. So that's always, that functionality always already exists. And there is better node management functionality in Docker Swarm as well. So Docker has tested 1,000 EC2 nodes and been able to run up to 30,000 containers on it. So that's pretty decent test, essentially. So let's see, how does Docker Swarm really look like? And in terms of Docker Swarm, what you have in the middle is managers, Docker Swarm manager, which is sort of a single point of entry for your administration. Yes, you have a primary master, but you can have secondary master, which can then be upgraded in case primary fails. So yes, it is a single point of entry, but not a single point of failure. And then on the bottom, what you see are agents. Essentially, these agents are where the containers are run. They could be spread across the cloud. Now, whether it's a master or an agent, those managers and agents really need to talk to a token service, essentially, which is where the cluster is registered. That token service, or a machine discovery, so to say, could be set up using etcd, console, zookeeper, pick your favorite, even a simple static file if you're on a closed network, as a matter of fact. Okay, so all the machines in the cluster register with that machine discovery service, and then your CLI, which is your Docker CLI, then is talking to the Docker Swarm cluster. So if I look at it in the Docker terms, I create the managers and the agents using Docker machine. I can use Docker Compose to run my containers and guide it to the Swarm cluster. So it's very straightforward. Okay. So one of the demos that I have seen, I'm not recommending this for production, but essentially you can create your Docker Swarm cluster on Google Compute Engine, Azure, EC2, and DigitalOcean. That's how your Docker Swarm cluster is created. Then you create an overlay network across them, and which allows the containers running on each of these machines to be able to talk to each other. So you have your database on one cloud, application on another cloud. Highly not recommended to do this in production. Okay, just be aware of that. So what I did is I wanted to run a multi-container application on a multi-host. So essentially, I fired up a Docker machine, run console as a discovery service over there. Then I started a master, which is again as part of a Swarm cluster. Then I fired up another machine, which is part of the Swarm cluster, registered with the discovery service. Fired up another machine, registered with the discovery service. Then I take a Docker Compose file, guide it to the Docker Swarm cluster. So my Firefly started on one, and Couchbase started on another one, and that's it. My application is live. If you want to run this similar application, you can see the link at the bottom of the screen, and that's where all the details are. Okay. So I think that's where I'm going to stop now, and I am going to switch to what are the other fun things that we can really do with Docker and IntelliJ together. Okay. All right. So let's go here. So now I'm in IntelliJ here. Okay. So let's go to IntelliJ preferences. So I presume you guys are all fully familiar with how to download IntelliJ. What I'm using is 2016 1.2 version for IntelliJ IDEA. I'm going to go to IntelliJ preferences. Okay. I am going to search for Docker, and it shows me here. Now, in my case, I have already installed the plugin. In your case, if you have not installed the plugin, it will give you an option to install the plugin. So you install the plugin, and you go through the drill, and that's it. So the plugin would be ready for you to do. Okay. So this is where it is. So what now Docker support is enabled per project. So what I'm going to do is I'm going to create a new project. Okay. I'm going to build a simple Java enterprise application. application server doesn't matter at this point of time. I'm just going to make a simple web application. Okay, go next. It needs a name here, so we will say Docker Java, and I'm going to click on finish here. Okay, so that's my project. If I look at the project, nothing fancy in here. All I have is just an index.jsp. Okay, so let's see how do I see the Docker window here. What functionality is available? So I say view and tool windows and Docker. So my Docker window shows up here. So I'm going to make this window bigger actually, so that we can all see it nice and clear. Okay. And this is one of the problems I have seen with IntelliJ sometimes. So I'm going to start it again. So it's not showing me the Docker pane here. So I'm going to get out of it here. Okay. And I'm going to start up my IntelliJ IDEA once again. Okay. Let's start it again. So you can see Ultimate 2016. By the way, that's one of the benefits of being a Java champion, that IntelliJ IDEA is available to all Java champions. So that's really cool. And of course, the community edition is available for everybody. But being a Java champion, you all get, if you're a Java champion, you should definitely be able to get a Ultimate edition. So I'm going to go back to View, Tool, Windows, and Docker again. And see, now my window is available over here. So if I go to command prompt for a second, I can show you Docker machine ls. Okay, you see my Docker machine is running. This is a command line that I use. I say, show me what machines are running. Only one machine by the name default is running. So let's go back here, and I'm going to say, go ahead, connect to the Docker machine. Okay, it is connected. It shows me the containers and images, and apparently none are there, so which is okay. So what I'm going to do now is, I am going to say pull an image. I can right click on the node and I'm going to pull an image, and here by default this is Docker Hub, registry.hub.docker.com. okay, so that's cool. Now I can click on new and I can create other registries because Docker Hub is a default registry that exists out in the wild, but you can create multiple private registries in your firewall. Those are typically very useful if you do the CI/CD pipeline kind of a thing, because with every change you may want to create a new Docker image, and then you may not really want to push that image to Docker Hub. It may have sensitive data, so you want to only keep it inside. So then you can create multiple Docker registries, but that can be configured here. For demo purpose here, we're going to use the standard Docker Hub. But all I'm going to do is I'm going to fire up and I'm going to pull a Couchbase image that I have created. Okay, so if I click on OK here, so it's going to pull the image for me here. Okay, so it's showing me the details here. It's pulling it here. Okay, give it a minute. It's going to pull the image. Now, if I go back here, if I say in command line, if I say Docker machine env default, it shows me what all variables I need to set, and if I'm running it in the command line side of it. These environment variables I need to set, and there is a convenient command for that. If I copy paste that command, so now if I do env grep docker, those variables are set in my shell. Okay. Now if I say Docker images, it shows me no images are there because that image is probably still being downloaded. And if I say Docker PS, it says no containers are running. Okay, and that's because we haven't started anything yet. So let's go back to IntelliJ. It's still pulling the image, and here now the pull is complete. Okay, so in the Docker tooling windows, you can see Arun Gupta / Couchbase image is downloaded. And if I do Docker images back in my shell, it says, yeah, the images exist as well. So that's cool. Now I want to fire up a container here. So I'm going to right click here and I'm going to run a container, create container, and I'm going to create it. Okay. So I can pretty much take all the defaults. I don't care about it. The key part here is I want to, because I know Couchbase port is 8091. So after launch, what I would like to do is I want to fire up the page 8091, which is my administration port. And then I can also go to container, for example, and I can go to port bindings, and I can say, by the way, allow me to expose port 8091 on the container to 8091 on the host. That's it. Very clean and simple API, simple interface here. let's go back to deployment here. Yes, there are a lot of configurations here available possible. We don't have to deal with them, but I think I love the simplicity out of it here. So now let's run it. So now it's running it. So let's make this window slightly bigger here. So we can see the image is running. It'll show me the log here, and it's showing me the attached console. So now here's the console. Essentially that image downloads Couchbase, runs it, configures it using REST API. The output of the REST API is shown in this console here, and the log is very straightforward as well. Okay, so that's cool. And then this is the page that automatically popped up for me in the browser. So let's refresh this page, and now the login page automatically shows up because the image is pre-configured, and I can sign in, and there you go, voila, I'm in there. Okay, so that's pretty cool. I can easily pull an image, I can easily run a container. Let's get a little bit more fancy. Okay, so now what I'm going to do is I created this project here. So let me make this window smaller. I created this project. I want to build an image for this. What would I do? So here, what will I do is I will go to IntelliJ IDEA, Preferences, and I will search for Cloud. Okay, I come to Clouds here, and let me delete this first of all. Okay, I'm going to create a new one here. So I'm going to make a new here Docker deployment. Okay, and the defaults work very well for me. I'm going to import credentials. I'm going to say detect, and it says connection successful. So it basically connected with the underlying Docker machine for me. So that's really good. Okay. So let's save it here. So I've created a new Docker deployment here. Now, in order to make an image out of this, this app is very simple, just a JSP page here. You can make whatever fancy you wanted. But what I'm going to do is I'm going to right click here. I'm going to say new directory. And the directory name is going to be Docker dir, for example. So I made a Docker dir here. And what I want to do is now when I build this project, I want to create this artifact, and I want to make sure the artifact gets exploded, or actually the artifact gets generated in this Docker dir. So let's go to the artifact here, artifacts, and I am going to change this exploded to say archive. Okay, and I'm going to call this as Docker Java. All right, so that's what I want to generate. I want to have this here, but instead of into the Docker Java out artifacts here, I'm going to click here, and I'm going to say generate this in the Docker dir directory. All right, so it's going to generate the artifact for me in that directory. So that's the first step we need. Okay, now here what I can do is I can right click here, and I'm going to create a new file here. Okay, this is going to be called as Docker file. Okay, in this Docker file, as I said, there are multiple repurposed images that can be repurposed. So I'm going to use the base image as jbus/wildfly, and I'm going to say add, which is my Docker Java.war file. That's the artifact that's going to be generated for me. And I know the deployment directory for wildfly is apt jbus wildfly standalone deployments. Okay, that's the directory where I want to copy. So that's my simple Docker file here. Okay, so I saved that. So now what I can do is I can actually run, and I can create a new configuration here. So I can go here, say edit configuration. This one exists, but let's get rid of this. So I am going to make a new configuration, which is for Docker deployment. Okay, I'm going to say image, or call it as Docker image, for example. So it's taking the Docker file over here. I don't care about the container name here. Okay, what I'm going to do is I am going to say before launch, I'm going to say add a build artifact, take Docker Java, which was the artifact that we just added here, and add it here, bundle it here. Okay, then after launch, what I want to do is I want to go to http 192.168.99.100, and this is going to be running in wildfly. Okay, so I'm going to take 8080 here, and I'm going to say my context root is Docker Java, and then I'm going to say index.jsp. Okay, so like that. And then when I go to container here, I can go to port bindings, and I can say, oh, expose container port 8080 on host 8080. Okay, So once I've done that, so let's go back to deployment for a second again. This 8080 is what's going to get exposed. Or I could have gone into container and I could have edited it, and I can say, oh, you know what, make the host port as 188. So then I go back in deployment and I change this to 188. Okay, so that's cool. Now I can say okay, and here is my Docker image deployment here. Let's see what does it give me. So I think we might be okay, and let's run it. So it's running it here, it's building the image. It's going to say, oh, I'm going to use say from jboss/wildfly, but that image doesn't exist. So I'm going to download that image, and you can see the progress right here. So it's going to take a few minutes to download the image. We'll wait for it in the meanwhile. But what we can also, while this is done, what we can also show you is how it allows support for Docker Compose. Okay. So now, while this image is getting downloaded, I'm going to right-click here, and I'm going to create a new file. Okay. So I'm going to call it as docker-compose.yaml. That's the file name where that's the default file name for Docker Compose file. Okay. So I have a code fragment that I want to copy here. So I'm going to copy this here, and I'm going to paste it here. Okay. This is a pre-built Docker Compose YAML file. Essentially, it has two services, DB and web. Container name is DB. Again, I'm passing the couchbase URI. Ports are exposed, and I'm using. I've just finished authoring Docker for Java developers book for O'Reilly, and this is a code sample from that book. So I'm using those images here, and that's it. So now this image is still being downloaded, but in the meanwhile, what we can do is we can edit configuration, create a new configuration which calls it Docker deployment, and this time I can call it as compose. And instead of saying docker file, I can say take docker compose.yaml. Okay, and I can click on OK here, and that's it. So now when I gonna run this deployment, so see now in my IntelliJ I have a Docker image or a compose. I can run the Docker image, and that will build the Docker image, and it will run it. And here it brings up my page from the previous run, and if I refresh it, it says end. Oh no! And why does it say end? Because that is the default template generated by If I go to index.jsp here, I can change this end to say hello world. Okay. Now I go back to say Docker image here, and let's go back here, get rid of this, and I am gonna run my deployment once again. So it's gonna build it, and it didn't like it. Fail. Oh, because the container is already running, so it says, hey, you know what, I cannot do it. So that's a good point. Actually, you can do a full container lifecycle management right here itself. So I can say delete container, for example, here. Okay, I can delete other containers. So let's delete all the containers right here itself. Okay, so I can delete the containers. So that container is gone, and that container is gone. And now let's try to run this deployment. Okay, so this has been deployed. Okay, so why our link didn't show up? So okay, if I look at it here, let's take this here, and oh, there you go, the link showed up. We're just a little bit impatient. So now when I refresh it, it shows me hello world appropriately. So you see how easy it is to create a Docker image. Now, one of the things I could have also done is, okay, this is good. So now I didn't give it an image name, so just use a random name. Essentially, I can take this image and I can push this image to the Docker Hub as well. So that's pretty cool. Okay, so switch back to the Docker Compose part we were talking about. So here is my Docker Compose configuration. Now, if I edit this configuration once again, I can see this is my compose. All it's saying is docker compose.yaml. So let's cancel it now. But here's my docker compose.yaml file here. But when I run it here, so it'll say, oh, it cannot find. Yeah, that's a bug actually I filed with IDEA yesterday. But for now, what we'll do is we'll go to preferences. I'm going to look at here, And then I'm going to say user local bin, Docker Compose for the moment. So if I say OK here and I say run, it's not able to find the Docker Compose directory, but essentially, it's saying, oh, you know what, DB uses an image, web uses an image. I need to download those images. If those images exist, that's good. If not, then I'm going to download them here, and I'm going to start showing you those images here. So you can see JBoss Wildfly is here, Arun Gupta Couchbase is here, the O'Reilly Couchbase images being downloaded actually. O'Reilly Wildfly is being downloaded. So all those images will get downloaded. Essentially, these containers will fire up, and you will see your application up and running. So I think that's, in short, if you see in the past 20 minutes, we saw how Docker support is ready and available in IntelliJ in terms of basic, Docker file, image creation, pushing images, integrating into your application development lifecycle and how you can easily create a Docker image. So a lot of fun things that are available in IntelliJ, and Andre will in a bit talk about what fun things are coming up as well. So if I go back to my slides for a second again, so if you go back to say Docker Mission, we talked about build, ship, and run. In terms of build, what they offer you is the ability to say Docker Toolbox, which allows you to easily create a Docker workflow. In terms of ship, they have Docker Hub, which is hub.docker.com, where anybody can create an account and push a registry. And then, of course, there is a commercially supported Docker Trusted Registry. In the run side of it, there is, of course, Docker Cloud, which used to be Tutum earlier. And then there is Docker Universal Control Plane, which allows you to manage and monitor your containers. And all of this sits on top of Docker Engine and a bunch of infrastructure. So one thing, several things we didn't get to talk about today is, for example, how when you're running a database, you need to map to a volume, because database is a stateful container. Typically, a container is a stateless. But for a stateful container, you need to map to a volume. So for example, you can use DVP or Docker Volume plugin to bind your NFS to a container and say, hey, the container is stateless, but the state is stored outside the container, so that if that container goes away, you can fire up another container and still bind to the same volume. So a lot of fun things that are available, and I'm sure as IntelliJ evolves in its Docker support, that will continue to move forward as well. So few links that I want to leave you here with. I built a Docker for Java tutorial, which is on github.com/docker/labs. So that's where you can find it. It's an extensive tutorial that's going to be delivered at DockerCon, has been delivered multiple places around the world. Once again, huge props to Docker Docs. Docs.docker.com is an awesome source of documentation. That is the best source, very easy to contribute, I would say. And then if you are particularly looking for IntelliJ documentation on Docker, you can go to jetbrains.com/IntelliJ/Docker. That is your one and primary resource. So with that, I will pass it back to Andre, who will talk about the roadmap.
Okay, so I'm turning it to my screen. And I believe we have time to cover a little bit of IntelliJ's roadmap and then answer all the questions we got. So as containers recently begin to get more and more traction, our team starts paying more and more attention to it, to one of the major options for deployment. Less than a year ago, our Docker integration was just one configuration. Now there is a separate tool window where you can manage images, containers, and even Docker Compose services. Yet, of course, there is a large room for improvement in terms of both functionality and UX. And we really appreciate your issues which you submit to our tracker. Here's a list of items on our roadmap for the nearest updates of the plugin. One of the missing features right now is manager Docker machines. Now you still have to switch to the terminal, as Aaron did, if you want to start or restart your Docker machine. Also, we plan to add more intelligent coding assistant features for editing both Docker file and Docker Compose files. These may include code completion, code analysis, navigation between configuration files and the Docker tool window, and probably gutter icons, so you can manage services right from the editor without switching to the tool window. Finally, we'd like to address one of the important limitations we currently have in our Docker Compose integration. Right now, you can't see services in the Docker tool window when they are down. This makes it a little bit difficult to manage them. Hopefully, this limitation will go away in one of the upcoming updates. I think that's it. I've covered all. And of course, one more time, a reminder. We keep saying it all the time. Whenever you miss a feature, just let us know immediately. The more detailed your feedback is, the more quickly we'll address it. So thank you everyone for your time, and we are looking forward to having you join us in future webinars.